So, hello everyone. My name is Jaymeet and today is the second session for C language. We already did the first session where we talked about different concepts of C. So, this is the series that is going to continue for total 5 sessions, out of which this is the second session. So, let's get started. First with a small, simple program. So this and the code that you are seeing right now is it generates the ASCII values for alphabets. You can use that in order to get it and also tweak some more and program some more in order to get a deeper understanding of different concepts of C. So let's get started with this. Today's starting is with functions. So function of why do we use functions in C and what are functions in C? So function of something means to have a particular task being carried out by that thing. So and that's a non-technical way of presenting it. So for in C's context, function in C or any other programming language means to have a task that can be performed whenever needed. So another explanation to it is functions break large computing tasks into smaller ones and enable people to build on what others have done instead of starting over from scratch. So appropriate functions hide details of operations from parts of the programs that don't need to know about them, thus clarifying the whole and easing the pain of making changes. So one of the reason to write functions are to use for code reusability also. So as I mentioned, reasons to write functions: avoid rewriting the same code over, and can break the and it also helps us to break the program into smaller tasks, making the problem easier to design. So we can write the function even if a function is being called once in the whole program, write separately to do some logically isolated task. So I will start with explanation of this and this program. So we have a function called sum, which passes which accepts two variable of int a and b, and returns the summation of it. So when in main it gets called with int add, and the value of a sum being stored in this, and then when we print it out, we get the answer to it. It's a really simple program in order to for a simple understanding of functions. So whenever a function is called, it gets executed. So main is called the function who calls the function, and the sum is here is called the called function. So starting with this, we have I have different simple programs already there. So you can see there is a function already mentioned within main, and this is the function. Just a second. So sorry for that. So let's continue to it. So there's a main function, and there is a function that is being called within main as message. So when message is being called, The control of the program being is passed on to the this function message until it's been executed. And when it's executed, the control goes back to the main function, to this main function again. So you can see first message displayed is the function message from function call, this one. And as soon as it is executed, you can see the control going back to the main function where this message is being displayed, this same one. Similarly, we can call the functions multiple times. So this is the same kind of program as before. And here I have also mentioned the number of times a function can be is being called. So we have our main function over here, and our message function which is defined here. And with each time the message function is being called, the value of I will be incremented. So this is the output to the above program. So you can see the control, how the control is being passed, and how many times the message function has been called. So you can count by counting the lines. You can see we have called the function 5 times. 5 times, 1, 2 in the program also, 1, 2, 3, 4, 5, and the output also shows that it's 5. And as we have also made a counter to the counter for how many times the function has been called, so it displays this. So 5 times has been called. So similarly, this is a different function which is called, and it also showcases the same thing of passing the control and calling the function. So here a function named fun is defined or made, and what it does is, if the value it accepts a value of n, where if the value of n is greater than 10 and smaller than 90, it will just simply give us the same value again. But if it's more than 90 or less than 10, it will add the number 32 with it and pass it on. So we have been asked to enter the number. So for 55 being larger than 10 and smaller than 90, use the result same as running it again for a number larger than 90 or smaller than 10. I'll start with smaller than 10 first. So it's 37. Again for greater than 90, 91. So you can see how the number and the control passes from from main being executed to whenever the function is called, the control passes to the function that is being called, and then as soon as the function is being called and there's nothing more to be executed by the function after that, the control goes back to the main function and executes and terminates the program if there's nothing more to be done. Next are pointers. So pointers can be done with 2 ways. So one is call by value and call by reference. So passing the value to the function and call by reference for calling the function with the help of the location of the function. So call by reference is basically uh, passing the address to the uh, as an argument rather than the value. So what we saw in the first example of sum was passing the value of it. In this one, we pass the value of it. And passing by reference means we are going to pass the address of it. So you can see something like this over here. This is the display of a simple address uh, in for an int I variable whose value is 3. So you can see the address of I, this is being displayed. So this is done whenever in printf statement we use the address ampersand for the variable, which will give us the address to the variable. And if we use it as we have been using printf with simple the mention of I, then we get the value to the variable. So, while declaring the pointer variable, asterisk is used, uh, which is also called as a value at address. So you can see the difference here. So starting the program, we have a normal declaration of variable I equals to 3. Then we have the declaration of pointer variable as star j. Now j will be uh, j will be equal to the address of I. So you can see different statements being executed here. And this is the address of address of I with respect to j, then address of j, and address of j with the help of address of j, then value of j, value of I, uh, value of I with the help of pointers, and value of I with respect to j with the help of j. So you can see the values and stuff that is being used here. The address of I, address of I with different things with the help of ampersand I and ampersand j, and then value of j with respect to its own address. Similar for the value of j, I, and I. Now, let's talk about the recursive functions. So recursion functions are functions that call themselves directly or indirectly. So this is a snippet from programmers. So you can see a program being on the lines of code, and what it does is it sums the number by asking for a number and all the numbers before it. So you can see by executing this program, we when we run the program, we are asked to enter a positive integer. As from this, we entered 3 and the summation of 3 till 0. So the loop is going to run until it meets the first if condition, which is n is not equal to 0. Until then, it will keep on calling itself until this condition is not met. So it's a recursive function, and as soon as this function is terminated, the control goes back to the main function, executes it, and gives and terminates the process of the program. So if you feel that that was a confusing explanation, there's the different explanation to it for the same program. So int main, we start with a result. We enter 3, then we enter 3 is not equal to 0, return sum, then goes back. 6 is written. Then actually it starts in this manner. So you can see it starts from 3 to 1 and 0. As soon as the 0 is done, it terminates the program and gets to it and gets out of it. So after talking about recursion and functions and how the control goes from main to function calls and again to the main function, let's talk a bit about data types. So we have already used int, character, float, double. So int is for integers, character is for character values, then float for decimal or fractional units. Then double is used for floating integers with more precision, such as in scientific calculations or financial applications. It provides great accuracy compared to float. So you can see different values of memory that are being allocated whenever a data type is used. It also depends on the hardware and architecture. So you can see that 32-bit CPU, we have different sizes and range, and similar for 64-bit CPU, and different size of memory is located, and different range is used. Okay, not different range, but different size. So after talking about the data types that are being used, we can also use it to save the store the variables in different manner. And how can we use it? So there are so we already talked about a variable being of data types. Now how can we how many times types are there in a way that we can use to store those variables in different ways? So it can be used so the variables can be stored in memory or the CPU registers. So you can see the reasons that where the variable can be stored, what will be the initial value if it's not specifically assigned, and scope of the variable and life of the variable. So these are the uh, can be the deciding factors of where to use the variables and store the variables. So there are 4 storage classes, which are automatic storage class, register storage class, static storage class, and external storage class. So starting with the atomic storage class, the storage is memory. The default value is an unpredictable value, often called as a garbage value. The scope is local to the block in which the variable is defined, and life of the variable is till the control remains in the block in which the variable is defined. And as soon as the control goes out of the block, it will not be the same. Moving further with a register storage class. So storage is a CPU register. The default value is a garbage value. A scope is the local block in which the variable is defined. And life is till the control remains within the block in which the variable is defined, similar to the auto storage class. Just a second, it's auto, not automatic. Sorry for that. Next is static storage class. So memory storage location is memory. The default value is 0, not a garbage value as compared to the previous ones. The scope is local to the block in which the variable is defined. The life is the value of the variable persist between different function calls. So there are there can be functions within a functions which are continuously changing the value of a variable. Now, when these functions will be changing the value of the variable, and those will be getting updated within the variables uh, allocation or assignment. So those will be persistent values, means that we will be able to use or carry forward the values of variable within different function calls and get the value. Let's say first function adds 1, second function adds 1, and third function adds 1. So the and our value is 0. So starting to 1, 2, 3. So we get the value of 3. Whereas if the same thing is done with auto storage location, the value that will be displayed will be 1, 1, and 1, because it the every time a function is called with the help of auto, it will be separately uh, uh, be dealt with rather than being a consistent value. So that is the difference between static storage and auto. So this is it for this session. And also, let's see if I've not missed any of this. So this was another program that I missed to. And that was the example for recursive. So you can see the function and sum uh, being made here, and then in in the in the main function it is called with this. So this function will keep on executing this statement until this condition is not met. As soon as this condition is met, or n becomes 0, it will pass on. It will pass on the state the control back to the main, and then uh, terminate the program. So you can see the sum of first 5 natural numbers is 15. So the summation happened over here, and then back to this, where this statement was executed with value being derived from this function being executed. This function being executed. So this is it for this session. Thanks a lot for listening. And my name is Jaymeet, and we'll continue this further. Thanks a lot.